can you tell us a little bit more about ISO PAS 8800? What's kind of new in it? What's it about?
Okay, so the intent of this document is to provide a framework to apply existing standards such as ISO 26262 for functional safety and ISO 21448 for SOTIF in the context of an element that's being used in a safety-related system that incorporates AI.
Hello and welcome to Ingenuity, the podcast series from HORIBA MIRA, where we go behind the scenes of next generation vehicle development. In each episode, I interview an expert in their field as we reveal the mastery behind the magic. I'm thrilled to be joined today by Dr. David Ward. Welcome, David. And I have to say, of all the conversations we've had, this is the one I'm most excited about because we're talking today about the rise of AI.
Yeah.
Now, can you give us a bit of a brief recap? I know we spoke about AI a little bit in our previous episode. Can you give us a bit of a brief recap about where we are?
Yeah, so as we mentioned previously, the received wisdom about the use of AI in safety-related systems has been to not do, but clearly we recognise that the world has moved on and there's a lot of interest in using AI and machine learning systems in applications where we want to have decision making that mimics human behaviour or is able to process data in ways that perhaps more traditional algorithms are not suitable for. So we recognise that there's considerable interest in the use of AI. For a lot of people, the focus is in automated driving and driver assistance systems, but it's seen as having benefits perhaps in more traditional control systems as well, where we want to take a set of data and learn from it and then adapt the behaviour of a system accordingly.
Brilliant. So what about the frameworks? Obviously, we're talking particularly about functional safety. Yeah. What about the frameworks that are being developed?
So in the automotive industry, the key framework to mention is a brand new document which has just been published called ISO PAS 8800, which deals with the safety of AI in automotive systems. So this is very specifically targeted about when we want to use an element that makes use of AI in a safety-related application. It builds on an earlier cross-industry framework called TR 5469 that was developed by the same group of experts as the ones that developed the generic functional safety standard IEC 61508. And indeed, that document is now being updated into yet another standard, ISO IEC TS 22440, which will be cross-industry framework safe use of AI. We're already seeing that some of the ideas, some of the principles that we developed in 8800 are now being taken on board in that document. So although we're very much focusing on the needs of the automotive industry, there's a lot of cooperation and interaction with the wider community to working on AI standardisation.
Oh, brilliant. So that's great to see that kind of cross-sector collaboration on such an important topic. So can you tell us a little bit more about ISO PAS 8800? What's kind of new in it? What's it about?
Okay, so the intent of this document is to provide a framework to apply existing standards such as ISO 26262 for functional safety and ISO 21448 for SOTIF in the context of an element that's being used in a safety-related system that incorporates AI. So I think one of the really important things to say, first of all, is that we don't do away or negate with those existing standards. They're still very much the basis on which we're working.
They're the foundation, if you like.
They're the foundation, exactly so. And 8800 then allows us to extend and adapt on those existing standards when we specifically want to deal with an element in the system that uses AI technology. So we still rely on 26262 for functional safety where the root cause is a malfunction. We still rely on 21448 for a situation where the root cause is a functional insufficiency. But now if a particular element is identified in the architecture of a system that uses AI, then 8800 is applicable as well. And one of the key things that 8800 does, for example, is it extends the vocabulary. So as you might expect, there's a lot of specialist terms to do with the use of AI. So we already talk a lot about things like functional insufficiencies and uncertainties in the context of SOTIF. For example, what we do in 8800 is extend the vocabulary to talk about some of the specific types of uncertainties that may be associated with AI. So just to throw out just to give two examples of that, we talk, for example, about epistemic uncertainty and aleatoric uncertainty. These are very specific to AI and machine learning. An epistemic uncertainty is to deal with how good the model is, and often if the model is perceived to have inadequacies, then it can be improved by training it with more data. Whereas the other type of uncertainty, that's perhaps due to noise factors in the data itself. So we recognise that there's another dimension of uncertainties that we need to deal with that's particular to this type of technology.
Oh, that's really interesting. So you've kind of, as you said, you've made that distinction between where some of the challenges with AI might come.
That's right, yeah.
So can you tell us some of the areas and topics that ISO PAS 8800 addresses?
Sure. So some of the particular topics that it addresses includes an AI safety life cycle. It includes how we derive safety requirements for AI-based elements and place those safety requirements on the elements. It covers the role of safety analysis in designing AI-based systems. It covers the use of data. That's a fairly large and important topic that we've introduced some new information on. It covers things like safety assurance, and all of what I've described there, of course, is an incomplete list.
And can you tell us some of the key differences then between ISO 26262? I know you mentioned it's the foundation, but there's a little bit of crossover, isn't there?
There is, yes. So clearly things like having a safety life cycle, deriving safety requirements, doing safety analysis are things which are there in 26262, but we adapt them in the context of 8800. Just to take one very specific example, we talk about some of the properties of AI, so things like AI controllability, AI explainability, AI resilience, just to pick three examples. And this is important because it gives us a framework that we can define properties associated with an AI-based system. We can attach some kind of measures or verification and validation criteria to them, so we have something that we're able to specify the performance of AI-based systems against, and then determine how good those systems are against that performance target.
So it's kind of like the AI layer, I guess, isn't it?
That's right, yeah.
So you mentioned controllability in terms of the new standard in 8800. Again, how does that differ from what's already in ISO 26262?
So interestingly here, both standards use the term controllability, but they actually mean quite different things. So in ISO 26262, where we talk about controllability, it's one of the parameters we use in a hazard analysis. So if there is a malfunction and the vehicle is in a hazardous situation, it's a measure that we use to judge how likely it is the driver or other traffic participant is able to take some action to control the situation and avoid an incident happening. In terms of AI, when we talk about AI controllability, it's effectively referring to factors outside the AI-based element that are able to detect and control the behaviour of the AI-based system. So to take some action if, for example, an AI-based system is working outside of its specified parameters. So one possible technical solution might be that the behaviour in an AI system is sandboxed in some way, so you let the AI system make decisions, but then you have an external monitoring element that checks that the decisions that it's made and the requests that it's making are within, say, a safe parameter envelope, and that's one example of what we refer to as AI controllability.
Right. So again, it's that specific context in terms of what you need to do to monitor, I guess, and evaluate the AI.
That's right, yeah.
So can you give us an example of a specific challenge that you're facing when you're talking about AI in safety-related systems?
Yeah, so let's pick on the topic of safety analysis. So this is a subject that will already be familiar to people working in functional safety. So in ISO 26262, we use the term safety analysis and often more specifically safety-oriented analysis to refer to the use of failure mode avoidance techniques principally during the design activities in order to identify potential causes of failure and make sure that we've specified adequate measures to deal with them. We also apply safety analysis to AI-based systems, but it's something that has a much broader scope. So clearly we still need to conduct analyses, perhaps, for example, based on properties of an AI system to ask what will be the consequence of property being violated, what measures do we need to put in place to help prevent or detect a violation of that property. So clearly there's still a big aspect in the design phase where we'd use safety analysis, but safety analysis is seen as extending to broader phases of the life cycle of a product, incorporating AI, for example, looking at the operation phases. And I think across many of the topics we've been talking about, there's very much a more iterative approach to some of these things like the safety life cycle, the use of safety analysis, etc. Also, we'd find, particularly when it comes to applying safety analysis, that some of the specific techniques we use might be different when they're applied to an AI-based element. So 26262 gives us some guidelines on selecting appropriate safety analysis techniques, but the ones that perhaps we see we need to use from a malfunction perspective may be different from the ones we need to apply to an AI-based element. So, for example, technique such as FMEA that many people will be familiar with is viewed in ISO 26262 as a so-called inductive analysis technique. It starts with a particular failure mode and identifies the consequences of that. Clearly, that's something that still has a big role in 26262, but we see that perhaps as something that's even more effective in the context of AI and would be part of the package of measures that we apply to analyse an element.
Brilliant. So, as you say, a much more iterative process than in terms of AI. Very interesting. So, you've given us a great insight into safety analysis. Can you tell us a little bit more about safety requirements as well?
Yes, that's another really important topic, because clearly in any safety-related system, one of the key principles that standards such as ISO 26262 give us is a framework of specifying safety requirements and then elaborating those into the design of the system. And the traditional model we have in ISO 26262 is that we take those safety requirements down to a relatively low level into the implementation of the hardware and the software. One of the challenges when it comes to an AI-based element is something like a deep neural network, for example, is quite a complex element, but it becomes very difficult to elaborate the requirements further inside the box, as it were. So we need a framework to deal with that. We can't say, oh, it's too complicated, it's too difficult to understand what's going on inside the box, but quite often we have to have a framework of safety requirements that we put on an element like this, and then be able to specify both quantitative and qualitative measures for those safety requirements and evaluating their fulfillment. So a quantitative measure might be something like a restriction on error rates, for example, which is something that's measurable. A qualitative requirement might lead to some of those approaches that we discussed earlier, such as having a safeguarding function that surrounds an AI-based element.
So really what you're dealing with here is uncertainty, right? And how you can kind of manage that uncertainty.
That's right, yes. And again, one of the frameworks that PAS 8800 gives us is some examples that we can apply at different stages in the life cycle of an AI-based element for evaluating and measuring uncertainty and specifying measures to improve our understanding of uncertainties.
Brilliant. And what's next? You mentioned that 8800 has been published. What's next for it as a standard?
So as a PAS, it represents an interim document. So we will continue work in the committee that's produced it. that work will look at a number of areas, one of which is to keep abreast of the state of the art and say, how does this document need to develop further? So working quite closely with the wider industry guidance, for example. There's a lot of work going on around metrics, measurable things associated with AI that we need to align to, and then ultimately we need to consider either a second edition of this document to take into account the progress that's been made in the technology and or developing it into a full international standard.
So that's one of the questions I wanted to ask you actually around generative AI. We're all talking about ChatGPT and various other generative AI models. How does that feature? What's going to be the kind of outcome for something like that?
Okay, so just a reminder that when we're looking at 8800, this is talking about AI that's used for the implementation of a function. But as you might expect, there's a lot of interest in the use of generative AI tools to actually support doing engineering activities. And also, as you might expect, something like that's quite a controversial subject with the usual range of opinions, from this is the best thing ever to no, we do not possibly want to go there. I think taking a pragmatic approach, we have to recognise that such things are going to happen. Some of these tools can be incredibly useful in helping us understand large sets of data, sets of information, but it's really important we look at a number of factors such as the integrity of information. If you put data into a public large language model, then there's the possibility of that getting assimilated into the collective, as it were, and that information subsequently being replayed. And I've heard some different views on how feasible that is or not, but I think an organisation that's interested in information security would need to think very carefully about how those tools were deployed and what was happening to data that was being provided. We also have to look at the quality of the data and the quality of the information that these tools are providing. To give you one example, I heard an anecdote in the early days of ChatGPT where someone asked ChatGPT about how ISO 26262 approaches the level of how ISO 26262 approaches the confidence that we require in software-based tools, and effectively ChatGPT gave an answer that was in the opposite sense to what 26262 requires.
Right.
I'm sure that's been addressed now, but that's just a very trivial example that even when we use tools like this, they're still tools. They need to be in the hands of expert practitioners. They need to be used to support the work, and we always need to check the information that's coming from these tools. But I'm sure that's a subject that there'll be a lot of progress, a lot of development on over the next few years.
Yeah, absolutely. And I think that comes back to, as you said, it's those checks and balances that we put in place. It's that evaluation of errors, of uncertainty. It's all the things that we've discussed actually with 8800 that are just as applicable in generative AI as well.
Yeah.
David, that's been an absolutely fascinating overview. I've really enjoyed it. I'm just wondering if we've got people listening that want to know more, what should they be doing?
So one of the key things that people could be doing is perhaps getting some training on 8800 and how we apply AI in safety-related systems in automotive. So we have developed a training course that introduces the topic, shows how 8800 can be used, and very importantly shows how that aligns and interacts with the existing activities in functional safety and SOTIF. It won't necessarily be a deep dive into all of the topics that are in 8800, but it will be a useful framework for people to get oriented, and then as they start to read the document itself and understand it and apply it, we'll then follow with some more detailed training in due course.
Brilliant. That sounds like a great place to start. And I'll make sure that there's a link included in the notes as well. Thank you again, David. It's been an absolutely fascinating conversation with you, as always. And I look forward to talking to you again in the future. Thank you very much.
Thank you.